Hello everyone, welcome to another episode of the series Single Variable Madness, where I take a normal, not so normal, one variable equation, and I solve it in a pretty creative way that you probably aren't taught at most schools. So let's look at this equation. Now this equation is pretty similar to the first episode's equation for single variable madness. It's 4 to the power of n plus 6 to the power of n equals 9 to the power of n. So, in the first episode, it was the last video that I did, but in the first episode, what we did was that we first tried to cancel out some stuff. In this case, we can't really cancel out anything. 4 to the power of n, 6 to the power of n, 9 to the power of n, they don't have anything in common that you can cancel out. So, what do we do? In this case, what we want to do is right away just start trying to make more variables. Now, I know that it is a single variable equation, but in a really powerful method to solving these equations is adding more variables into the mix to make it a little bit easier to understand. So, how can we do this? Let's see. Well, you might notice something kind of interesting. If we set a as 2 to the power of n, a equals 2 to the power of n, and if we set b as 3 to the power of n, and check this out, 6 to the power of n right here is just a times b, right? Because 2 times 3 is 6, so a times b equals 2 to the power of n times 3 to the power of n, which is equal to 6 to the power of n. So, we can use this. And keep in mind, 4 to the power of n is just a squared, right? 2 to the power of n times 2, so that's 4 to the power of n. And 9 to the power of n, well, that's just b squared. 3 to the power of n times 2 equals 9 to the power of n. So, let's rewrite this equation using these variables. So we have 4 to the power of n, a squared. 6 to the power of n, a times b. And finally, 9 to the power of n, b squared. There we go. We have this sort of easier equation. It's not that much easier, but it does give us a route that we can take, and that is the quadratic formula. Let's take a as the variable here. So a is a variable, and let's pretend b is a constant. So let's bring everything to one side. We have a squared plus ab minus b squared equals 0. Well, this is kind of like a quadratic equation, right? If you treat a as the variable, well then it would be a squared plus ba, because you usually have the constant in front of the variable, minus b squared. So this would be your a squared term, this would be your quadratic term, this would be your linear term, this would be your constant term. So let's use the quadratic formula, because why not? We can do that, right? So we have a, which we're treating as our variable here, equals negative b, in this case it is actually negative b, plus or minus the radical b squared minus 4ac, so minus 4 times a, which is just 1, so we don't have to write anything, and then times c, which in this case is negative b squared. Okay, and then we have all over 2a, in this case 2. So, kind of terrifying, but let's solve it a little bit further. So you get a equals negative e plus or minus, so we get b squared plus 5b squared. So we can factor out a b, or b squared, sorry. So we get b squared times 1 plus 4, and then, so that's just 5, 1 plus 4 is 5. Now we can factor out the b in the b squared in the square root to just b and take it outside the square root, which we did right here. So we have negative b plus b times the square root of 5. And then what I did here was that I factored out a b. Now I don't want to factor out negative b, sorry, I misspoke. I'd rather factor out just a normal b. Now, and another thing I forgot is that there's still plus or minus. Remember, quadratic gives you two solutions, so you need that plus or minus. So after factoring out a plus b, you get a minus 1. Sorry, making a lot of mistakes, don't know why. So minus 1 plus or minus the square root of 5 divided by 2 equals a. What do I do from here? Well, let's try this. Let's divide, we have A and we have B now kind of off like with each other, not really added to anything else. Let's take B and bring it to A. Let's divide B on both sides. We get A divided by B equals -1 plus or minus the square root of 5 divided by 2. So now is the time where we can get rid of the A and B and just use this. A is equal to 2 to the power of n, B equals 3 to the power of n. So A is equal to 2 to the power of n, B is equal to 3 to the power of n, and that is equal still to -1 plus or minus the square root of 5 divided by 2. Well, we can factor out an n on the left-hand side to get 2/3 to the power of n equals this. However, now we can get rid of the plus or minus, because keep in mind, anything to the power of a real number, I forgot to mention that n has to be a real number. If any number is to the power, if any positive number is to the power of a real number, then that's going to give you a positive number, not a negative number. So we don't want -1 minus the square root of 5 divided by 2. That will give us a negative number. Instead, we want -1 plus the square root of 5 over 2. Because -1 plus the square root of 5 over 2 is, as a matter of fact, we can also write as square root of 5 minus 1 divided by 2. That is a positive number. In fact, it is more than a positive number. It is actually 1 divided by the golden ratio. So the golden ratio is 1 plus the square root of 5 over 2. 1 over the golden ratio is the square root of 5 minus 1 over 2. So I'll let you work that out on your own. But now, eyes on the prize here. We're trying to look for n. So how do we do that? Well, this is just a simple logarithm change. All we have to do here is say log base. What will the base be? Well, the base is 2/3 of this, which I'm just going to substitute as 1 divided by phi equals n. And there it is. Our answer is log base 2/3 of square root of 5 minus 1 over 2. And that gives us the answer for this equation. So we did have to do a substantial amount of work, and I did actually make some mistakes. You might have saw some edits and some whiteout right here. But anyway, that's the answer. If you have any other way to solve it, please let me know in the comments and make it a great day.